Hello, I'm Jonathan, and I'm here representing HPCToolkit. So for those of you who haven't heard of us before, here's the brief introduction. As we all know, the most important aspect to high-performance computing is achieving high performance. And the key to achieving high performance is being able to measure your performance and tuning your application to improve it. This is where performance tools come in. Performance tools let you know where in your application your time is being spent or being wasted. And HPCToolkit is, of course, a performance tool. In fact, we say it's a best-in-class performance tool built for HPC at scale. There's a number of things that make HPCToolkit unique, but I've chosen 4 things here. First, it's easy to use. We run on optimized applications and don't require any intrusion into your source code or build system. You just run your code as you normally do, and we measure it. Second, it's fast. We use a sampling-based measurement strategy. That means we get quality performance data with minimal application slowdown. In our tests, we usually end up with an overhead of maybe a few percent. Third, it's detailed. When we attribute performance, we attribute it down to the individual instructions, and in practice to individual source lines. Because as we all know, all it takes is one line before your fast application becomes a very slow one. And finally, we're scalable. Whether you're working on a single compute node or scaling out to the full size of an exascale supercomputer, HPCToolkit is able to give you performance data all the way through. Once you have your data, you can use one of our GUI interfaces to analyze it. On the left, I have our code-centric view, where you can see you can dig down your calling context and see the exact functions and source lines that are causing you all your performance. Or you can, for more complex analysis, you may want to use our time-centric analysis, where you can see the activity of your application across all the different threads, across a cluster, across a supercomputer, etc. We have broad compatibility across the board. We support all major CPU and GPU vendors, as well as a wide variety of programming models. In orange here, I've marked the things that we plan to release in our coming release this year. And then in purple, I've marked a couple of things that are still in active research. Speaking of research, I should introduce our core development team. We're a research group at Rice University. We have a mixture of both research staff, students, and a couple of external affiliates. And if you want to hear more about us, feel free to visit our website, hpctoolkit.org. There you can find our documentation, tutorial videos, publications, stuff like that. Okay, with that, this is HPSFCon, so I should talk about the HPSF. For us, joining the HPSF is a rather big change in direction for our project. We're a research group, and that means that we're always trying to push the boundaries of what performance analysis can do. But a lot of the time, that means we end up having to focus on the issues of interest to our sponsors. So in our case, our sponsors tend to be the Department of Energy, U.S. National Labs, and then occasionally we have some vendor or industry partnerships. That means that we have over 2 decades of experience battle hardening our software on leadership supercomputers, on scientific applications, but it also means that when it comes to new trends sweeping HPC, we often tend to lag behind. It has to be of interest to our sponsor before we even get a chance to really work on it. And that happens only once there's an application that's using it, and then at that point we're playing catch up. So the HPC landscape is rapidly evolving, and we all are feeling this more than ever. And our current approach of handling this is simply not keeping up. And so that's why we've joined the HPSF. We feel the HPSF has the potential to change that. It gives us a direct connection to the broader HPC community so that we can continue doing what we do best. We have a number of goals here. I've just sort of, mostly in terms of community engagement, I've just sort of summarized them out as 4 points here. First, we want to interact with the broad HPC community. We want to understand what HPC developers are doing and how our tool can fit into your workflow. Second, we want to build a community around our project. And by community, I mean a group of users, stakeholders, and we really want contributors. This will help us better understand what our tool needs to do, what our users want to be able to do, that sort of thing. Third, one of our goals is to establish open standards for performance tooling. And this relates to a rather complicated issue of that the runtimes that we see out in the wild are getting increasingly complex. And although a lot of them have performance tooling, it's often insufficient, and we need to make it better. And so by getting better tooling, we can get better, we need better tooling before we can even get quality performance data, and we want quality performance data to achieve high performance. And so an open standard is one way, among others, that we can, as a community, express the kind of performance tooling that we want in these runtimes. And finally, as a community, we would like to engage vendors and projects to improve their performance tooling. We've often argued with many vendors to improve their tooling, sometimes successful, sometimes not so much, but we feel that by making this a community effort, we can improve the ecosystem as a whole, we can get performance tooling, we can get performance data, and we can, in general, grow the ecosystem forward. As far as our current involvement, we're participating in the CI and benchmarking working groups. As you've heard, the CI working group is spinning up HPC critical resources for testing purposes. So we've started moving our continuous testing from our machines at Rice over to the machines available from the HPSF. And these are architectures like the MI300 or Intel Data Center Max, things that you don't normally get from like cloud providers just because they don't have them. And so moving forward, as this gels, we intend to make these resources available to our contributors as part of our testing system. The other benchmark we're working in is the other working group we're working in is the benchmarking working group. And for that, it's still in its infancy, but we're hoping to assist in assembling the codes and launch scripts to evaluate system performance. For us, this as a performance tool, we're mainly looking for this to use as a suite of applications that we can then test our tool, demonstrate that our tool works, because after all, the best way to demonstrate that a performance tool works is to run it on an app and show its performance. With that, that's all I have, so thank you for listening, and I'll take questions.
Okay, we have time for a couple questions, since Jonathan went quickly. Anyone have questions about HPCToolkit? Awesome.
Thank you. So as part of joining the HPSF, have you looked at the various codes and libraries that are part of the foundation that you could use as ways to get the benchmarks instead of writing the benchmark again, but like natively? Like there is already like a lot of things that exist.
Yes. So so for us, we're doing. Our plan is to use codes that are already present in the foundation. We're not going to be writing benchmarks ourselves. We want to make it real applications that are of interest to the community. So.
Okay.
Yeah. Thanks. Question is, so with the idea of having an open API or open standard for performance, how do you expect to manage like very different architectures, right? You may have very different kinds of compute platforms. And, is there a process for keeping all of that like in one place, or how do you map those together? What are you thinking?
Sure. So I'll admit that it's sort of pipe dream stage at this point. It's more something we know we have to do, and the details are still in development. When it comes to whatever it is, we do need to handle the wide diversity of platforms, and that's something that is just going to be a challenge, and we have to discuss as a community to figure out what that means.
Hi, yeah. Can you just give me a couple of examples of what you mean by bullet 4 there? Vendors and projects. Give me just 2 concrete examples of something you need from a vendor and something you need from a project.
Sure. I blanked on a good project one, but in terms of vendors, I definitely have 2 examples. We've been working with, talking directly with NVIDIA and so to give an example of what we've done, for Intel, we ended up sending like a 4-page letter that was just literally a list of complaints about, okay, this API doesn't work, doesn't give the numbers we want. This API doesn't give useful numbers. We're missing an entire class of performance here, etc. So, that's the kind of engagement that we've done so far. As far as what we want to do moving forward, we would like to have something as a community that we can say, you should implement this API. You should do things this way, and be able to encourage the vendors to actually do it that way.
Do you see this as, is one of your aims for this to be used for providers, HPC providers, for things like acceptance testing and continuous monitoring of the resources?
By this, do you mean HPCToolkit or
HPCToolkit with like a suite, using a performance API for like a provider to just gather information on for acceptance testing or continuous monitoring?
Sure. So HPCToolkit is primarily targeted towards developers. You have an application, you have an HPC application, you want it to run faster. That's the usage model we've always run with. Acceptance testing is definitely a part of that, and that's something that we've neglected for a very long time, and so we want to grow that part of our tool as well. But yes.
So over the years, watching HPCToolkit and the business models that it has, seems like you bring a lot of value to the vendors, but you don't get paid very much, if all, by them.
Yeah.
You need access to the features that they are building in their new devices, but they don't give you that information. And when they do, they change it, the APIs. And I'm just saying these things because maybe HPSF, and is there a way for those things to change because HPSF is around?
Essentially, that's what we need, and I'm hoping that HPSF will be able to bring that change. And that's, in fact, really why, calling for open standards and calling for community engagement. I believe that's the way that HPSF can help, although I'd love to discuss more options.
So you've been talking about the ability to collect data from a variety of places. Have you given any thought to having open standard for the format of the collected data so that different tools can be used to analyze the results? That is a significant problem I've had with tools in the past.
So I won't say that. So to answer the question of, there are open standards for performance data. In our experience, those open standards tend to fall flat on certain aspects. So say, they don't handle sparse data well enough, or they don't handle certain kinds of GPU runtimes well enough, like certain kinds of GPU data well enough. And that's in part because, the kinds of performance they were collecting are different now than they were ever before. And so the formats themselves have to change in order to adapt to the fact that the very data nature of the data that we're putting in is different. So I'm open to open standards. We can definitely have a discussion about what we need as toolkit and what you need as whatever performance tool, whatever analysis you want to do. I think that's something we should discuss. Yes.
Okay, and I think. Oh, did you? All right. Dave's presentation is short.
Yeah, John Melick, I work on the HPCToolkit project as well. So rather than using an open standard for recording the data, we're recording in our own compact proprietary formats. Well, proprietary just meaning it's our format. Anybody can use it, but it's unique. Okay. However, we have built a Python API that can scrape the performance data out, so you can put it into a Jupyter notebook or something like that. So we think that's an appropriate way to have it is to have an API to get at the data, rather than having a standard that you would like to see.
Thanks.
Thank you.